I'm going to explain combinations of resistances here. Dear student, already have studied this topic in the class 10th. It is given very clearly this one, and I hope maybe all of you know how can we find the equivalent resistance in either in series combination or in parallel combination or in mixed combination also here. So generally, in many practical applications, two or more resistances are required to combine. And this can be done in two ways, mainly in series. Second one is in parallel, and third one is called mixed combination. And in the mixed combination, some resistances are joined in series and some are in parallel. So first I am taking in series, and I want to give again here how can you find the equivalent resistance in the series combination. Suppose three resistors R1, R2, R3 be joined in series between A and B. And suppose the end A and B is connected to a cell, and the cell is sending the current I. So always remember this, in series combination, the resistance are joined end to end. End to end means second end of each resistance be joined to the first end of the next resistance, and so on. So here like the second end of R1 be joined to the first end of R2, second end of R2 be joined to the first end of R3, and so on. So this combination is called series combination of the resistances. And in series combination, the current in each resistor will same. Means suppose the cell is sending the current I, so same current I is passes through this R1, same current passes through this R2 and R3. It means in series combination, current in each resistor will same, but the potential difference across each resistor will different. Let V1, V2, V3 be the potential difference across R1, R2 and R3. Net potential is V. So here we can write here V is equal to V1 plus V2 plus V3. It means applied potential difference across AB, V. Potential difference across each resistor V1, V2, V3, and already I told you in series combination current will remain same but the potential will be different. So V is equal to V1 plus V2 plus V3. Now V1 is the potential difference across R1. Now current in this R1 is I, put resistance R1, potential difference V1. So by Ohm's law you can write this V1 is equal to, by Ohm's law, V1 is equal to IR1. Similarly, V2 is equal to IR2 and V3 is equal to I into R3. Now, at place of V1, V2, V3, you can put these values here. So now you can write here V is equal to I R1 plus I R2 plus I R3. Or simply you can say V is equal to I here R1 plus R2 plus R3. Now, if these three resistors R1, R2 and R3, अगर ये तीनों resistors R1, R2, R3 को replace कर दिया जाए इनके equivalent resistance के बराबर, it means suppose at the place of these three resistors, if we put a single resistance or resistance are equivalent, then same V, same current I is passes through it. And now we can write V is equal to I of the potential difference across it is V. So V is equal to I into R equivalent, where R equivalent is the equivalent resistance of R1, R2, R3. So now in this formula, V is equal to I R1 plus R2 plus R3. Now at place of V, we can write I into R equivalent. So you will get I into R equivalent is equal to I R1 plus R2 plus R3. So I is cancelled by I, and simply you can say R equivalent is equal to R1 plus R2 plus R3. It means in series combination, the equivalent resistance is equal to the individual sum of their resistances. And always remember this, in series combination, the equivalent resistance B always comes greater than the greatest resistance in this combination. Suppose 2 ohm, 4 ohm, 2 ohm, 4 ohm, 6 ohm. Suppose these three resistors be joined in series. So here greatest resistance is 6 ohm. So when you will calculate their equivalent in series combination, so it will comes 2 plus 4 plus 6, and this will come here 12 ohm. So this 12 ohm comes greater than the greatest resistance in this combination. It means, dear student, if in any circuit you want to increase the resistance, किसी भी सर्किट में अगर रेजिस्टेंस बढ़ाना है तो उसके सीरीज में एक हाई रेजिस्टेंस जोड़ दे. And when you will add a high resistance in series, overall the resistance of that circuit will increases. So what is the main point in this one? First thing, in series combination, the current will remain same, but the potential difference will be different across each resistor, and the equivalent resistance you can calculate R equivalent is equal to R1 plus R2 plus R3. Now, second combination is what here? Combination of the resistance in parallel. And in parallel combination, one end of each resistances be connected to one point and other end of each resistance be connected to other point here. For example, here suppose three resistance R1, R2, R3 be joined in parallel between the point A and B. And now this A and B is connected to a cell of potential resistance B. Suppose this cell is sent the current I, or the current coming from this cell is I. But this I will reach at the point A, it divide in three parts. Suppose the current in this resistance R1 is I1, current in resistance R2 is I2, and current in resistance R3 is I3. It means this current I, which is coming from the cell, is divided in three parts at the point A. It means this current I is the sum of I1, I2 and I3. It means here we can write I is equal to I1 plus I2 plus I3. And always remember this, in parallel combination, the current in each resistor will be different, but the potential difference across each resistor will remain same. Suppose the potential difference across this one is V, then the potential difference across this one will also V. Potential difference across this one is also V. It means in parallel combination, current in each resistor will be different, but the potential is remain same. While in series combination, current in each resistor be same, while the potential is different. So both is reverse. So in this case, I is equal to I1 plus I2 plus I3. Again, you come on the first resistor. Resistance of this one is R1. Current I1. Potential difference across this one is suppose V. So by Ohm's law, we can write V is equal to I1 R1. Or simply we can say I1 is equal to V upon R1. This. Similarly, for second resistor R2, V is equal to I2 R2 or I2 is equal to V upon R2. And similarly, V3 is equal to I3 R3 or I3 is equal to V upon R3. Now, at place of I1, I2, I3, you can write this value V upon R1, V upon R2, V upon R3. So, you can see here I is equal to V upon R1 plus V upon R2 plus V upon R3. Now simply you can say here I is equal to V and take common here 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now, if all these three resistance, अगर ये तीनों रेजिस्टेंस रिप्लेस कर दिया जाए एक सिंगल इक्विवेलेंट रेजिस्टेंस से, इनके इक्विवेलेंट के बराबर अगर एक सिंगल रेजिस्टेंस लगा दिया जाए, and suppose this one is R equivalent, current I, potential difference V, same current I will come now. So we can write V is equal to I into R equivalent. I is equal to V upon R equivalent. Now at place of this I here, we can write V upon R equivalent. So finally we can write V upon R equivalent is equal to V 1 upon R1 plus 1 upon R2 plus 1 upon R3. V is cancelled by V, and finally you will get here 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. But by using this formula, you can calculate 1 upon R equivalent. So finally, for finding the R equivalent, what value you are getting, you will take the reverse of it here. So from here, you can calculate the R equivalent in parallel combination. And dear student, always remember this. In parallel combination, the equivalent resistance becomes smaller than the smallest resistance in that combination. Suppose again, 2 ohm, 4 ohm, 6 ohm. Suppose connected in parallel, the smallest resistance is 2 ohm, and when you will calculate its equivalent resistance in parallel, then that equivalent resistance will come less than 2 ohm. It means if you want to decrease the resistance of any circuit, then you add a small resistance in parallel. So what I told you, first, if you want to increase the resistance of any circuit, then always we add high resistance in series. And if you want to decrease the resistance of any circuit, then always we add a small resistance in parallel. And the use of it also, I will explain you how we convert a galvanometer into a meter and a galvanometer into voltmeter. So conversion of galvanometer into ammeter and voltmeter is simply depends on addition of these resistances series and in parallel. Now the electrical energy and power. I hope maybe this topic is also you studied in the class 10th, but here once again I would like to remind you, electrical energy means energy consumed by an electrical appliance. Suppose I am taking a black box. In this black box, simply any box which contains some electrical device. It means inside the black box, maybe there is any motor or any resistor or anything here, which is the electrical device inside the box. So black box is not any device. Inside this black box, I am taking either resistor or any motor, anything like this one here. And suppose that is connected to a battery and this one is a key. Suppose this current I is set up in this circuit, then the electrical energy consumed by that electrical appliance which is inside this black box, suppose potential difference is V, current is flowing through it is I, and suppose in t second the electrical energy consumed by it is given by W is equal to V I T. This is the direct formula for calculating the electrical energy consumed by an electrical appliance. Across this the potential difference is V, current flowing through it is I, and in t second this amount of the electrical energy be consumed. But suppose inside this black box, if I am taking a resistor, so in that resistor the electrical energy be consumed in the form of it will comes in the form of heat energy. So that time the electrical energy we can calculate W is equal to what I am taking here. Suppose any resistor R. So when you will take a resistor R inside here, then at place of V by Ohm's law you can write IR and here already IT. So you can write this one is I square RT. And Also, you can write here W is equal to, if V is equal to IR, then I is equal to V by R. So either place of V, when you will write IR, then electrical energy through that resistor you will get I square RT. And also you can take at place, also we can take at place of I, V by R. So same relation, this W becomes W is equal to V, and at place of I we can write V by R into T. So this becomes V square by R into T. It means the electrical energy in any electrical circuit is calculated by W is equal to either VIT, or this one is I square RT, I square RT, and also we can write this one is V square by R into T. It means the electrical energy can be consumed by any electrical circuit either VIT or I square RT or V square by R into T. Now the next topic is electric power, because already I have given electrical energy and electric power. So electric power is what? The rate at which an electrical energy is transferred into other form of energy is called electric power. And rate at which electrical energy is transferred into other form, it means this P is equal to W by T, where W is the electrical energy and T is the time. And from this formula, W is equal to VIT or I square RT or V square by R into T. When you will take W by T, then here you will get VI, or W by T you will get here I square R, or W by T you will get V square by R. So the electric power P, so the electric power P is equal to W by T, and when you will take W by T from here, we will get here P is equal to VI, R, this is equal to I square R, R, this is equal to V square by R. It means the electric power can be calculated by this formula VI, I square R or V square by R. And the unit of electric power, the unit of electric power is W by T, means joule per second, and this joule per second is also called watt. It means 1 watt is equal to 1 joule per second. So simply you can say electrical energy and electrical power can be calculated by using this formula. And the bigger unit of power like kilowatt, and 1 kilowatt is equal to, as you know, 1000 watt, or you can write here 1000 joule per second. So in this way we can calculate the electrical energy and power. Next topic is illumination of electric bulbs in parallel and in series. It means if the different power bulbs are connected in series or parallel, then which bulb will be illuminate maximum, और अगर ढेर सारे बल्ब जो अलग अलग पावर के हैं अगर उनको सीरीज में या फिर पैरेलल में जोड़ा जाए तो कौन सा बल्ब सबसे ज्यादा इल्यूमिनेट करेगा, मतलब कौन सा बल्ब सबसे ज्यादा प्रकाश देगा. Dear student, always remember this: the illumination of any body or the illumination of any bulb is depends on how much electrical energy is giving by that bulb in form of heat energy. जो बल्ब जितनी ज्यादा इलेक्ट्रिकल एनर्जी को हीट एनर्जी के फॉर्म में निकालेगा वो उतना ही ज्यादा ग्लो करेगा. जैसे हम एक सीधा सा एग्जांपल लें, सन हमको लाइट दे रहा है, हीट दे रहा है, बट इनसाइड द सन वहां पे कोई बल्ब तो लगा नहीं है. Inside the sun, nuclear fusion process is taking place, and in nuclear fusion, large amount of the heat energy is released, and due to that large amount of the heat energy, it gives the light in form of electromagnetic waves. So simply you can say illumination of the electric bulbs. So illumination is depends on which bulb is giving the maximum electrical energy in form of heat energy. So if different power bulb, if different power bulbs are joined in series, are joined in series here, then the lowest power bulb, then lowest power bulb will glow maximum. It means if different power bulbs are joined in series, then the lowest power bulb will glow maximum. It means in series combination, the lowest power bulb will be consume the electrical energy maximum in form of heat energy. जैसे हम कहें 40 watt, 60 watt, 100 watt. Suppose these three bulbs are joined in series. अगर ये तीनों बल्ब सीरीज में जुड़े हैं किसी सोर्स से, तो जिस बल्ब का पावर सबसे कम है, ये 40 वाट, ये सबसे तेज जलेगा। क्यों? क्योंकि इस केस में इस बल्ब के कारण जो इलेक्ट्रिकल एनर्जी हीट एनर्जी में कन्वर्ट होगी वो सबसे ज्यादा होगी। बट if different power bulbs are joined in parallel, but in parallel, the highest power bulb will be glows maximum. It means जिस बल्ब का पावर सबसे ज्यादा होगा वो ज्यादा इलेक्ट्रिकल एनर्जी को हीट एनर्जी में कन्वर्ट होगा। तो इन सीरीज 40 watt bulb will be glows maximum, but in parallel 100 watt bulb will be glows maximum. And dear student, you know, in house, अपने हाउस में जो भी हमारे इलेक्ट्रिकल अप्लायंस लगे हुए हैं ये सब पैरेलल में जुड़े हुए हैं। इसलिए अगर एक कमरे में आप 40 वाट का बल्ब लगा दीजिए, एक में 60 वाट का, एक में 100 वाट का, तो 100 वाट वाला बल्ब सबसे तेज आपको प्रकाश देगा। क्यों? क्योंकि ये सब पैरेलल में है। लेकिन जो छोटे छोटे बल्ब जो डेकोरेशन पर्पस के लिए यूज किए जाते हैं वो सब बल्ब किस में जुड़े होते हैं? वो सब सीरीज में जुड़े होते हैं। अगर उनके बगल में हम एक 60 वाट का बल्ब लगा दें तो 60 वाट के बल्ब का प्रकाश इस छोटे से बल्ब के प्रकाश की तुलना में बहुत ही कम होगा। क्यों? क्योंकि सीरीज कॉम्बिनेशन में जो सबसे कम पावर वाला बल्ब होता है वो सबसे तेज चलता है। तो इन दिस वे वी कैन फाइंड द इल्यूमिनेशन ऑफ द इलेक्ट्रिक बल्ब्स इन पैरेलल एंड सीरीज। Now the last topic is commercial unit of electricity consumption. I hope maybe this topic is also given in the class 10th, but again I would like to remind you, electrical energy consumed by any factories or in house, the cost of the electricity is paid on the basis of how much electrical energy is consumed by the factories or in your household appliances here. So the new unit is used to measure the electricity cost, and that unit is called kilowatt hour. Dear student, be careful about this one. Kilowatt hour is the unit of energy, not power. So the electrical energy consumed by the household circuit or any factories, it is measured in kilowatt hour. And this kilowatt hour is also called in short term board trade unit, BTU. And this board trade unit is in short also called only unit. And 1 kilowatt hour, actually this one is a unit of energy. This one is 3.6 into 10 to the power 6 joule. And 1 kilowatt hour is also called 1 unit. So 1 kilowatt hour is also equal to what here? In 1 unit. And we paid the cost of the electricity consumed by our houses in terms of the unit, कि हमारे घर में कितने यूनिट बिजली खर्च हुई, और जो भी एक यूनिट बिजली की कॉस्ट होती है उससे हम मल्टीप्लाई करके निकाल लेते हैं कि इस पर्टिकुलर मंथ में बिजली की कॉस्ट कितनी आई है. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule, and actually 1 kilowatt hour is also called 1 unit. Now, the number of unit consumed by any electrical appliances is equal to power. That power is measured in watt into time. That time is in hour upon 1000. By using this formula, direct we can find out how many unit electrical energy consumed by any electrical appliance whose power is given, and for what time of that electrical appliance be used upon 1000. And when you know the unit, how many unit of electricity we consume, and when you will multiply by the cost of 1 unit of electricity, then you can find out the total amount of the electricity bill which is paid by any factory or household circuit. So dear student, what topic I have discussed today here, once you go through this one also with the help of your book here, and now you try to solve the numerical problem which is given in this exercise. But first you go through all the example, you solve the numerical problem based on series and parallel combination of the resistances, and also how can we calculate the commercial unit of the electricity. And finally, in the next video, I want to discuss some numerical problem of this chapter, and then we will start the next chapter. Thank you.